All right. Hello, everyone. Welcome to another stream. I'm trying out a few new things. I set up over the weekend a new mic and the stream deck and all of that fancy stuff. So hopefully this is working okay. If not, I have a back channel with my team just in case. And yeah, just let us know in the comments if anything is going wonky. Awesome. Well, today we're going to be talking about manipulating and cleaning data. So there's actually a Jupyter Notebook up on our GitHub repo, which you can see here. There's also so if you go to github.com/Microsoft/reactors, there is an online folder, and in there's a Jupyter Notebook called Manipulating and Cleaning Data. Looks like this. It's got a bunch of extra text in it, but you can run this in any kind of Jupyter Notebook experience that you prefer. So I'm going to be doing it in VS Code. So you can see I've got my VS Code open. I'm actually going to be starting with a blank file because I just want to kind of conversationally go through some things with you today. I've already installed the Python extension to VS Code and installed Anaconda and made sure that I've got NumPy and Pandas installed. So if you are going to try to do this, make sure that you do all of those things. We have some resources on the repo, but in general, basically you just need to kind of install all those things and search around on the internet, and VS Code has some great docs for that, so check it out. So we're going to get started today. Quickly, I just wanted to remind y'all that this is part of our online reactor series. So the reactors are over 10 locations now around the world, where typically we come together in a beautiful space and we learn new things, whether it's about data science, AI, web development, kind of anything. Our team goes and delivers these in-person workshops. Reactors also host community events. So if you are a community organizer, you run a meetup, whatever it might be, you can actually use the Reactor spaces typically for free. You just have to sign up online. So you can check out the Reactor, just search for Microsoft Reactors and check out the site there. Unfortunately, right now, the physical locations are all closed, which is why we're bringing you these live streams. So we're really excited to have y'all here. Okay, I'm going to turn off my face so that I can save on some bandwidth here. And let's go ahead and get started. Okay, so first of all, I wanted to start talking a little bit about data frames. So if you missed the last stream, don't worry, we'll be posting it on YouTube. But if you missed the last stream, basically we're using the Pandas library, Python library, and we are exploring data frames. So the first thing that we need to do is import Pandas. So that's this right here. You'll notice that I also have the IntelliCode extension turned on, so it allows us to get that autocomplete. So if you run, it should work if you have your environment set up with the right Python and Anaconda and all of your libraries installed. To just first explore some of the data, like to understand the data that you're exploring. Wow, that was a really horrible sentence. When you're first exploring data, is the sentence I meant to say, one of the great resources that you have is the Pandas library, and in it there's an object type called DataFrame. And so to explain this, I want to bring in a really large data set. So I'm actually going to use one of the data sets from scikit-learn, the Iris data set. It has 60,000 rows and 400 columns. Okay, so this will allow us to kind of start to understand what it, like the extent to which data frames help out. So let's bring that open over here. Okay, perfect. So the first thing that we're going to do is import the iris data set from scikit-learn. So we'll say from scikit-learn datasets import load iris. Awesome. A couple things to remember about Jupyter Notebooks. This is true whether you're in VS Code or not. Again, you've got some of this IntelliSense and autocomplete inside of VS Code. You can click on this little eye to bring up the documentation, so you can see this is the iris data set. You've got a bunch of information about it here, some examples, etc. So that's just kind of a reminder there. And also if you hover over things, so I can hover over the scikit-learn module, I can hover over data sets, and that gives us some documentation as well. Perfect. So now I've got my data set. The next thing I'm going to do is I'm actually going to load that data into a local variable. Okay, let's make sure that works. Awesome. One thing that I really like about Jupyter Notebooks is that you can do this more iterative development. And so the way I like to explore data is a little bit more like, okay, I want to try one thing, and based on the result of that one thing, I might do something else. So that's what I really love about it. That's why I'm doing it in this more iterative fashion rather than loading that entire notebook and just kind of walking through it, because this is how I might do it if I were actually exploring it on my own for the first time. Okay, the next thing I'm going to do is I'm going to convert the data, or I'm going to like store the data into a data frame and have a variable name to represent it. Okay, so I'm going to create a data frame, and the data is going to be iris data. And I want the columns to be the feature names. Okay. So let's go ahead and run that. Now here's the tricky thing, like how do we know if that actually worked? Like what is in iris data? I mentioned the iris data set has 60,000 rows and 400 columns. So I don't want to like print all of that out or view all of that. But I do want to make sure that this is like the accurate data and that I actually have the right things in here. So what I'm going to do is I'm going to run iris info. And this is going to tell me in this variable, so not in the actual iris data set, but in this particular variable that I just created, what's going on here? What kind of data is in there? So let's check it out. So we can see that we've got 4 data columns, and in each one we've got these specific data columns, and in each one these are the values that we have there. So .info, when you're dealing with a data frame, is really useful for just kind of understanding what your data frame has, what's inside of your data frame. Another really useful feature or function, rather, of data frames is to actually print out the first few lines of your data frame. This is really useful because it allows you to get this, it allows you to get an understanding of what your data looks like, right? Again, if I was just exploring this for the first time and I was told, oh, check out this data, I might not know what this looks like. And I don't necessarily, like the whole point of doing it inside of a Jupyter Notebook is I don't necessarily want to, print it all out or open it in Excel or anything like that. I want to explore it within this notebook. And so I might not have ever seen what it actually looks like. And by the way, iris data is about flowers. So yeah. The .head function allows us to print out the first 5 rows of our data. So we can see that it's all in centimeters, that the numbers are in this type of range. That gives us an understanding of like, if we did want to start to filter based on some kind of information, these are the ranges of numbers that we're seeing. Again, there could be like 20 centimeters in sepal length. Like, and by the way, I don't know how to pronounce that word, to be honest. I always just read it, right? It's kind of like Hermione. I never knew how to pronounce it until the movies came out. So forgive me if I'm saying it wrong. There might be like a value of 20 later down in the data set, but this kind of gives us an understanding of what we're seeing. So what if I wanted to return or show or print out more than the first 5 rows? By the way, when I ask questions, I tend to pause a little bit longer so that you can also think about it. What I'd probably do is look up the documentation for data frames, to be honest. When you're first learning something new, the best thing to do is to have that documentation handy. Again, luckily with VS Code, we have it right here. So we can see that there is actually a default parameter for the head function. So it's defaulted to 5, but we could change this to 10. And then it would show us the first 10. We could even change this to 100. And it would show us the first 100. It does do this like ... because again, the point of using the Jupyter Notebooks and especially in VS Code, but in general, it would do this with any Jupyter Notebooks, is not to view all of the data. The point is to explore the data programmatically. So they're not going to show you hundreds of thousands of rows. That's not the point. If you wanted to do that, open it in Excel or in some other application. The point is to kind of just get a general understanding. Awesome. So that's useful, but if our data is sorted in a certain way, maybe it's sorted from, smallest to largest petal width, we would also like to see the end, potentially. So again, if I'm doing, autocomplete, we can actually get the all of the functions that are available for a data frame, so you can kind of just explore these. Based on my previous coding experience, if something has a head, it probably has a tail. So we can go see right here. So data frames also have a tail function that allows us to see the end of the data frame. So we can see that we have a total of 150 rows. We knew that because up here in Iris DF info, it said that we had 150 entries, 0 to 149. But we can see the last few entries as well. All right. So that's all we're going to do with the Iris data set at the moment. It was really just kind of an opportunity for me to show you some of the critical functions that data frames offer to allow you to start to understand what is in your data frame. So again, those 3 functions were info, head, and tail. And actually, I'm just going to change this back so then that way it's easier to scroll. And, again, tail is has a default of n equals 5 for the last n rows, so you can change that as well. Awesome. All right. So next, we're going to talk a little bit about what we might do if we have missing data. In real world situations, you're not likely to have clean 100%. This is all of the data that you need. You're likely to have missing data. You're likely to have data that's slightly wrong. So that's the whole point of this stream, is we're going to talk a little bit about how you can start to clean and manipulate your data to make sure that the data that you're drawing conclusions from is accurate and accurately representing what you're trying to measure. So I actually kind of want to talk about that a little bit. I'm going to turn my face back on for a second, because I think this is a really important point. When I first say cleaning and manipulating data, you might think, well, then if you're manipulating the data, aren't you drawing conclusions that are wrong or that are off? No. The problem is that data is dirty. Data is not always accurate. People fill out forms incorrectly. Sensors gather incorrect information. maybe it was left in the shade when it was supposed to be measuring sun, and for some reason somebody put an umbrella over it. I don't know. Just data can be messy. And so the point of the exercise of cleaning and manipulating data isn't to change the data so that you can change the conclusion, but rather to make sure that the data is accurately representing what you're trying to capture, what you're trying to understand about the world around you. So then that way, when you do draw a conclusion, it's an accurate conclusion based on the real data and not based on anomalies or based on incorrect or dirty data. So I hope that makes a little bit of sense. It is kind of like the first time that I heard the phrase, oh, we're going to do some data manipulation before we draw conclusions, it was like, are you trying to trick me? But it really is a critical point, a critical step to data science. Okay, face off. So the next thing that we're going to do is we're going to start to explore how we might want to get rid of missing information. Now, you might not always want to get rid of missing information because maybe the missing information tells part of the story. But it is important to recognize when getting rid of missing information is important. So, for example, if we're trying to understand, I need to write down these examples before I stream. But if you're trying to understand, whether or not people who are over a certain height, I don't know, have a certain shoe size. I don't know. I'm just totally making it up. And your data has an anonymous person with a height and a shoe size. And for some reason, some people didn't put in their height. You probably want to get rid of the people who didn't put in their height because that's not going to accurately help you understand whether or not their shoe size correlates to their height. And so when you're doing your data science and trying to draw your conclusions, you might have some functions that say if height is greater than X. But if the data is missing from that column for that particular row, then that might inaccurately get added to your data set, skewing your results. Does that make sense? So I wanted to be clear about this because it's not always the case that you want to get rid of missing information. But it is important to understand when there's missing information, what that missing information is, and whether or not you should get rid of it. And that's a really critical piece to data science as well, is understanding that it's not just about knowing how to code, and it's not just about knowing how to manipulate and clean data. It's about also understanding what is the data that you're dealing with and why are you cleaning and manipulating it in that way. Okay, so to get started with this, I'm going to import NumPy. Okay, and I'm just going to create an example array inside of NumPy. Okay, so I'm going to call this example1. And this array is going to contain some integers, but it's also going to contain a none value. So basically a missing value. None comes from Python. So when none is in the array, then you're likely working with a Python object, not with a NumPy object. But we're gonna explore this right now. So here's my array. So let's go ahead and print it out. Okay. And the issue with having a none type, so basically essentially like a null type, a missing value, is that when you do try to perform some kind of actions, like maybe adding all of the values in your array, you get an error because none isn't an integer, right? You can't add none to numbers. So because the interaction, like the operations that you might perform on an integer don't work with none, you might want to get rid of those values, and we'll explore how to do that later. In addition to none, we also have another kind of null data type, and this is nan. Okay, so nan. Nan is specifically a missing float type, so basically a number. None is essentially a missing object, like it's just missing data. Nan is missing float type. So we saw that when we tried to add 2, none, 6, and 8 using the sum operation, we got an error. So before I click this, I want you to predict what you think will happen when I run this one. So this actually gives us nan, not a number, basically. This is really important to understand because, again, if your data has none null kind of object types, and then you try to perform operations and you get an error, that might be a feature. You might want to get an error so that you know that there's missing data there, and you might want to clean that data or change the none to a 0 or a -1, depending on the data that you're dealing with, or just remove that entire row completely. But if your data has the nan, the not a number, versus the none, then when you try to perform an operation, it's not going to throw an error. It's instead going to replace or just always result in nan. That can be good, but it's very, very important to know what's going to happen to your data when you're going to run these operations. Now, if you're doing this in this kind of sequential way in Jupyter Notebooks, it's going to be obvious, right? Like, I see this, I'm going to run an operation, I get an error, or I get a nan. The important part comes when you're trying to do these aggregate operations across thousands and thousands of rows and columns. You want to make sure that when you perform these operations, you're putting in the data that you meant to put in. And we'll kind of go through that a little bit more. We can see that this is true even without addition. For example, with multiplication, we'll also get the same. And we can see that this is true. I mean, you know, in the above example, we did an array instead of just literals. So let's go ahead and try that. So we have an example 2. Let's go ahead and just make sure that that's what we expected it to be. Awesome. And notice that, remember, nan is a float value. And so then it upgraded all of the integers to floats as well. So that's why it's 2-point implicit 0. So we can do, you know, sum like we did before. It's going to result in nan. What do you think would happen if we did this? Do you think it would be 2 or nan? Again, it's always very important to predict on your own, even if you're just kind of listening and you're not trying it, because that allows you to learn better. If you predict and then someone tells you the right or wrong answer, or the right answer, and you were right, then it reinforces that understanding. And if you were wrong, then it helps your mind change to the correct answer. I'm kind of a learning science nerd. So it does do nan. Probably expected. I mean, that's kind of like null. It's kind of like that, yeah, lowest number. But what do you think would happen here? Is nan truly like the smallest number, or is it independent of that and will always just result in nan? Essentially, it's independent of that. And this is, again, why it's really, really important to know how operations will work with particular data types, specifically the data types when you're missing data. Okay. What do you think would happen if we tried to do something like, I'm going to go ahead and take this, but I'm going to do another example. Let's call this example 3. Let's call this example. Yeah, I'll just call it example. And we did this. So now we've got a nan and a none type. So let's go ahead and just see what this looks like. Okay. And then what do you think would happen if we did this? If you remember, anytime we try to add none to float types or integer types or whatever, we would get an error. And remember, nan is technically a float type. It's a non-value float type. So we'll still get that same error. you can see here the error. So nan is a float type, none is a none type. Okay, I'm going to go ahead and we're going to move on a little bit. I'm going to create an integer series. Okay, so this is a series in pandas, and essentially kind of like an array, if you will. I'm going to specifically say that this is of type integer, not of type float. Let's go ahead and print that out and see what we've got. Oops. What did I do wrong? Hang on. Did I spell? Oh, capitalization. Perfect. So series is kind of like a data frame. It's kind of like a table. So we've got this like these 3 rows, and these 3 rows have these values. So row 0 has the value 1, row 1 has the value 2, row 2 has the value 3, and it's of type integer. So can we do something like we're going to try something like, oops. Int. Oops. My non-Python is showing. So we can change values in a series. What if we tried to do this though? What do we think would happen? So remember, we created this series and specifically said it was of data type int. And now we're trying to replace the 0 row value, which I replaced with 5, but now we're trying to replace it with nan. So it did replace it with nan, and then it upgraded the entire series to floats. I would say that kind of makes sense in terms of what I would expect. I'm going to go ahead and recreate this because I want to test that out with none. So I'm going to recreate this. This is another reason I really like Jupyter Notebooks, is that you can, again, play around with the data that or the variables that you're doing without having to rerun an entire program. And you can kind of see the progression. When I'm looking back at this later, I can see the progression of what was going on. And that's what's really valuable with these numbers here, is it tells you in which order things were run. So I could have actually come up and just rerun this. I prefer to just have it be sequential though. Okay, so let's go ahead and do this now. Okay, I see that there might be some buffering happening. So we'll hope for the best here. It's always hard to tell, especially with everyone working from home, whether the buffering is on my end or other people's end. But it sounds like there's a little bit of buffering happening. So again, just as a reminder, this will be posted on our YouTube channel on Friday. So the Microsoft Reactor YouTube channel. All right. So this actually changes the none to a nan, and it upgrades it to float. When I first ran this, I didn't expect that to happen. I expected this to be an error. So again, it's just really important that before you do these aggregate operations on large data sets, that you understand how different data types, like especially these missing value data types, are going to play. Okay, so that's great. But again, we're not necessarily going to be showing all of the data. Like we don't always want to print all the data. Our data sets are not going to be 1, 2, 3, or, just like 4 variable or 4 integers. So we do want to have some understand how to use some of the functions, that'll allow us to get an understanding of what kind of values are in our data sets. So let's do another example. Let's create another series. And this one's going to have a 0. I'm also going to put in a nan, and I'm going to put in a string, and I'm going to put in a none. Okay, just kind of like have them all. I always like to print it out just in case. So 0, nan, empty string, and none. Kind of like all the zeros. You can use this function to determine whether or not there are null values. So what do you think this will return? It actually returns a series of Boolean type with true or false for each row, whether or not it's a null type or a null value. So we can see that 0 and empty string are not null. Those are perfectly valid values, but nan and none are both nulls. All right. So what if you did want to try cleaning up? By the way, sorry, before I do that, we can also do something like this, which will give us the opposite, right? What if you wanted to try to clean up all of your null values though? So let's say that, I don't know, let's take that height and shoe size example. Let's say that you didn't necessarily want to be super accurate and you had gender, age, height, and shoe size. Okay, so I'm just going to change this over and I'm going to kind of explain my little example here. So I'm going to have a data set and I'm going to have 4 like columns, and they are going to be gender, height, or age, height, and shoe size. We know that there's some correlation between height and shoe size. We know that there's some correlation between age and gender and height. So this is why I'm kind of pretending like I have this. And let's say that there are some people where there are, let's say that there are no null values here. Let's say that there are no null values here. And let's say that there are no null values here. But there are some null values here. How do you think we might do this where, you know what, I don't need it to be super accurate. Therefore, if the height is missing, I just want to get the average height for that gender and age and put it in there. Again, this is not going to yield super accurate results, but let's say that I don't really need it. What do you think would happen if we did something like, I don't know, 60 inches. Oh, I'm going to need to put that in an actual Python cell that can run. So now what happens is that anytime it finds a null value, which we know is null because it showed true up here when we did the is null, it's just going to replace that value with 60. So this is really useful in case you wanted to do, you know, a sum on all of your values for something. And you might have some none values. And so you want to make sure all of your none values go away. You could do this. So this is an example of doing it where you just kind of took the average of what the other values might be. You could also do it where maybe you made them 0. And so then you say anything, or you made it -1 and then that just kind of like, or sorry, 0 would probably be more accurate. And then I don't know. Anyways, I'm just rambling about a data set that doesn't exist. So I'm going to stop. So that's one way where you can actually replace all of the null values with a value that makes sense for your data set and the conclusions you're trying to draw. But again, what if you did want to completely get rid of the value, any value, row, whatever it might be. You wanted to completely get rid of the values that were null. So let's go ahead and we see, let's actually recreate, and I'll do it this way. How about, I'm going to recreate example 3. So now you see that's 35. So if I were to print example 3 here, just to triple check, we have our nan and our none again. Okay, so we've got our original example 3, and now we just want to drop anything that's null. No problem. We can drop nan, none, basically anything that's a null value, and NA value, a null value, something nan, none, etc. We can actually just drop those completely. Good. Sounds like the audio is much better. I'm really sorry if you turned up the volume and then all of a sudden I got really loud. All right. So now I'm going to go from a series to a data frame. The biggest difference here is a series is essentially 1D and a data frame is bigger. So let's go ahead and create a new data frame. So I'm going to create 3 rows with 3 columns. Okay, so this is our data. Trying to make sure that you get your brackets right can be tricky. I'm always hyper paranoid about that. Okay, so I've got a data frame. Pretty sure this is the one that I want. Let's make sure that this is working. It'll print it out much prettier for me. Perfect. So now I've got 3 rows and 3 columns. So my first row contains 1, nan, and 7. My second row contains 2, 5, and 8. And my third row contains nan, 6, and 9. Okay, notice that the values in these 2 columns, 0 and 1, got upgraded to floats, whereas the values in column 2, titled 2, the third column, did not. And that's because nan is, again, a float value, and we're assuming that it's an individual kind of entry per row, and columns represent the same data type, right? So you might imagine that this is like age, height, and shoe size, and then this is person A, person B, person C. So what do we think will happen if we do example 4 dot drop NA? Do you think it's going to drop rows 0 and 1, or sorry, 0 and 2? Or do you think it's going to drop columns 0 and 1? Again, use the indication of what got upgraded to a float as kind of a hint there. It drops the rows because, again, the assumption here is that what your row is an individual person, and then your columns represent those data. So what we want to do is we want to drop any data, any individual person, any individual data that has null values anywhere in it. But what if you did actually want to drop? So let's make sure example 4 is still our full one. Because remember, if we didn't do example 4 equals, then it's not actually changing the value in our variable. It's just performing the action and printing it out for us. So we still have all of our values here. If you did actually want to drop any columns that have missing data, you could do that as well. You just change the axis. And this might be useful if you had a column that just, you know, if there's any missing data, then it just makes that column useless for some reason. I don't know why. You just really want to keep all of those unique people. And so any column that has missing data, you want to get rid of it so that it doesn't skew any of your results. Okay. Let's check out this. So you can just show, you can just drop certain null values as well. Sorry. I totally just said that all wrong. Example 3 didn't work because we don't actually have 3 because we only have 0, 1, and 2. So let's say that we wanted to create another, and example 4 doesn't, oh my gosh, I'm just all messed up. Let's say that we wanted to create another column, but we just wanted to fill it all with null values. Maybe we want to do this because we want to create the column and then later we want to fill it in with like the average of columns 0 and 2 or something like that. I don't know. But you just want to create a column that has all null values. You can do that here. One thing that can be useful though is if we want to drop any null values where we want to make sure that there's at least 3 real values. So basically what we're doing is for each row, we only want to drop that row if there's at least 3 non-null values. So if we were to run this again and change it to 2, we wouldn't actually drop anything because they each have at least 2 values. So again, this can be useful because if maybe there's just like a lot of data that's missing from a particular row and you just want to get rid of any data that's missing from a large row. Again, the really critical part here is to understand that you really need to know what your data is doing and why. These are just some of the features that you can use. Okay, we're going to move on. I'm going to create a new series. It's going to have some null values again. It's going to have some integers again, some nones, some 3s. And this time I'm actually going to specifically say that the index is this list of characters. So the index is that list. That means that I'm specifying that, what did I do wrong? What did I do wrong? PD. So that means that instead of just having some random 0, 1, 2, 3, I'm actually naming my rows this time. Okay. I'm also going to show you a new feature where quickly, instead of just doing the is null, like, you know, example 5 is null equals something, we can actually just do it all in one shot with fill NA with 0. Okay. So I'm going to fill all values that are null with 0. Oh, sorry. I'm not actually saving it there. What if you did this though? So again, all of our values are, I mean, I originally put in integers. The nan upgraded them all to floats. So they're all floats. But what if I try to replace it with a string, an empty string? Remember that series, it doesn't matter what the values are, so it can totally just replace it with the empty string. And now they're not floats, they're actually upgraded to objects because string is the higher order object or type. So this is a really neat one. So let's go ahead and just print example 5 again so we know what we're dealing with. So we've got the null we've got the nan values. You can actually front fill. There's quite a few different methods that you can use for filling null values. So you can actually front fill, and what this means is it'll take the value before it and fill it with that. So now we get 1, 1, 2, 2, 3. And you can do the same, but you can backfill. And so this will bring it the other way. So this is probably most useful if you're doing some kind of, in order list, because then you could say, it's probably about the same as before. So I'll give you a concrete example of this. I'm using that Noom app to try to be healthier, and it requires me to put in my weight every morning. And sometimes I forget to weigh myself, so I'll just put in the weight that it was yesterday. And instead of me manually doing that, I could get all of my data and just, backfill and say, or front fill, whichever order my data's in, and just say, yeah, just grab the one from yesterday, because my weight between day to day necessarily doesn't change that much. It's more my weight over weeks. And so if I miss like a day here and there, then I might want to front fill or backfill there. Okay, so we can do the same thing with data frames as well. So let's remember our example for data frame. We can do the same thing here for filling. Method, front fill. It's really confusing putting in the front fill with FF and LL across that axis. Oops, equals. Cool. Notice that this one didn't get filled in, and that's because it's front filling. So this one will take the value of the previous element, 1, but this one there is no previous element. And similarly, we could do a backfill. Again, like I mentioned before, you might want to take like the average of something instead of just filling it with the value next to it. So we can do the same thing here. I encourage you to just kind of explore all of these different ways of filling in data. And again, it really just matters. What am I example for? It really just matters what you are, what your data is and what you're trying to achieve. So we'll notice that this column didn't get filled because what we're doing is we're getting the average from that row. So what was our example 4 again? Our example 4 was this. And so our null value was this one right here. The average of 5 and 6 is 5.5, and the average of 1 and 2 is 1.5. The average of nan is nan. Those are just going to remain all nan. All right. We've got a little bit of time left. I want to go through duplicates a little bit. And then there's going to be a lot more data on the Jupyter Notebook. And actually, we can do some more exploration of these in the future. But you can also explore this in the Jupyter Notebook. I really just wanted to start to give you an understanding of how you are exploring this and why. So let's go through one last example around duplicates. So we're going to create another data frame. And this time we're going to have, we're going to specify what the column and rows specifically are. So we're going to have letters. And so we're going to have A, and we're going to have B. And I'm going to do something tricky here. Okay, so I'm going to do 2 plus B. I want you to try to predict what's going on here. Numbers, and we're going to do 1, 2, 1, 3, 3. So what the heck did we just do there? Apparently nothing good. Invalid syntax. Where's my invalid syntax? Numbers. Oh, that's the one. There we go. So we have 2 columns, letters and numbers. We have 5 rows. In letters, we have A, B, and we're going to do that twice. So A, B, and then we're also going to have B. And then in numbers, we're going to have 1, 2, 1, 3, 3. Okay? So notice this like operation that I did to create that column. If you watched any of our previous streams or watched the videos on YouTube, those kinds of operations with lists and series and just kind of general arrays and things like that we've covered. Let's take a look at what is duplicated here. Duplicated. We can see that for each row, whether or not that row is a duplicate of another row. So A1 and A1, and then B3 and B3. So the first A1 is not a duplicate because it's the first, it's unique, it's the first one it's seen. And then the second one is a duplicate. And this can allow us to, number one, see just kind of like if there are any duplicates. But number two, we can then use the drop duplicates function to remove any of the duplicates. And again, that might be useful because maybe somebody filled out a form twice, and so they have the exact same information twice, and we don't need that information because we're trying to get averages of something, and I don't know. Especially useful if it's somewhat more identifying information. What if we only wanted to drop duplicates in a particular column, though? So we didn't need it to be that you dropped the duplicate had to be the entire row, but just the entire, just the column. Again, maybe you have someone's name or an identifying number or something like that. So you only wanted to have one instance of each person. So we can do something like that as well. So that's going to drop all the repeats of A and B because we have it once here. So A1 and B2, A1 and B2. But then A1, B3, B3, where those A and B's are duplicates in that same column. So we want to get rid of those. Okay, I'm going to stop there. The next section on the Jupyter Notebook is about merging and joining data frames, which will also be super useful. The feature is on or the data that we're playing with is like employees and groups and things like that. So it should be fairly straightforward. I'm going to switch back to this view. Hello. Now you can see my big, huge mic that is now directly in my face. But that's just kind of a brief introduction into cleaning and manipulating data, the importance of it, why it's important to understand how null and none and just kind of like empty values, how they play a role in operations that you're performing. It's important to understand the data that you're playing with. So then that way, or not just playing, but like exploring and trying to draw conclusions from. So that way, if you do try to replace a null value with something, you don't necessarily want to replace it with a -1 or 0, just kind of blanketly. You might want to know, what is this data that we're actually doing? You might want to replace it instead of an actual value like the average of something or, previous rows values, etc. So I just want to reiterate that when you're cleaning and manipulating data, these examples are somewhat contrived, but I really want you to challenge yourself to come up with examples of why you might want to use certain features over another. And when you are exploring data sets, play around with that as well. It's really, really important to understand the data that you're exploring and the conclusions you're trying to draw and the relation between those when you're doing this kind of cleansing and manipulation of data. So I hope this was helpful. Don't forget to join us every Tuesday at 4 p.m. Pacific time and Thursday at 9 a.m. Pacific time here for more live streams. Every Friday, we post these videos up on YouTube. So if you missed any of them, you can go check those out. We also do a live Q&A on Twitter, where we ask you some questions and just try to engage with you all around like specific topics. So you can check that out. If you have any questions for me, you can feel free to reach out on Twitter. Thank you all for joining. Have a good one.